Hello learner, greetings of the day. The OpenGL functions required to perform two-dimensional viewing we are going to discuss in this video. We'll start up with some of the basic OpenGL functions that is very much required to perform viewing, that is two-dimensional viewing. So to begin with, we will start with the projection mode, OpenGL projection mode. How to set up, or what is the OpenGL function to set up the projection mode in a program or in the graphics. In order to obtain a 2D image, or in order to obtain the image of any 3D graphics, in order to obtain display that or render that image on the display window, it is very important to set up this mode, and that mode is projection mode. The OpenGL function required to set up this projection mode is GL matrix mode, and the parameter that you set up here is GL underscore projection. Remember, it should be in all caps. So the matrix mode here, there can be two modes. The first mode is model view mode. By default, you can if at all you don't set up the mode as projection, by default the matrix mode will be set to model view. So keep this in mind. So model view is a mode, and the next important mode is projection mode. Now since we have set up the mode to projection mode, we are now ready to render the graphics on the display window. So the final display, if at all we have to obtain on the display window, the mode must be projection mode. If at all you set up the mode as model view, we don't render, we don't get to see the graphics displayed on the display window. So after specifying this GL matrix mode, now we are ready to set the initialization. So the initialization is set with the help of OpenGL function GL load identity. So this particular function doesn't have any parameter as such to be passed. So if at all you call this load identity, an identity matrix is set up. And we all know what is identity matrix there. All the diagonal elements are 1, so rest all the other elements are 0. So here the matrix mode, once you set up the matrix mode, before you apply any transformation onto the object, before you define any object, first and foremost the OpenGL function load identity should be called. So the moment you call this particular function, you can see here the identity matrix is loaded, and this particular matrix gets multiplied with the projection mode. Basically, what is projection? I hope you all have gone through the video of viewing pipeline. So the previous video was all about the viewing pipeline. So as per the viewing pipeline, we carry out series of transformations in order to obtain the image of any graphics on the display window. So what is that series of transformations? So first you start from the object or model, and then you go for the world coordinate system. That is, you represent this object in a world using world coordinate system. Then using a camera, you capture this particular object or image of this particular object, and you render that on the clipping frame, or you render that within the clipping window boundary. So once you have that in the clipping window boundary, you perform the clipping there. That means which desired portion of the object you want to finally render. So that selected area you choose, and then you map that particular chosen area onto the viewport. So that mapping is done in the next step, and that is nothing but normalized device coordinate. You set up a boundary there, you normalize your image to -1 and 1, that is the lower limit and upper limit. So once you set up your boundary, or once you map from the window to the viewport, now we are ready to display that onto the device. So here a device can be a mobile phone or the computer screen or a tablet. So here what is projection? The projection is nothing but this stage. That is, you're moving the graphics from the clipping area onto the final display window. So in order to render the graphics on the display window, the mode should be projection mode. I was saying about the one more mode, that is model view mode. So what is that? That is nothing but the first stage, that is mapping the object onto the clipping coordinate or onto the clipping window. So mapping the object to world and then world to the clipping window. So this series of transformation is nothing but model view. So I was saying that this is a default mode. So in order to render the graphics onto the display window, you must set the mode as projection mode, and it's always safe to set the first matrix as identity matrix. So after setting the identity matrix, now you are ready to apply any transformation onto the object. Like you can call GL translate, then GL rotate, then GL scale. So all these transformation functions you can call after you set the identity matrix. Let's see now the clipping window function, OpenGL clipping window function. Remember, in order to set the 2D clipping window, we have an option. So we have a function, sorry, not option. We have an OpenGL function. Remember, this is a 2D clipping window that we are setting with the help of the function GLU ortho 2D. Remember, it is not GLUT or it is not GL. The prefix is GLU because this particular function is defined within the library glu.h. So GLU ortho 2D is a function, and remember we have 4 parameters that has to be passed for this particular function. So what is a clipping window? It's nothing but a rectangle in shape. It is rectangle in shape with the boundaries there, 4 boundaries there. So you have to start from the left boundary, then move to the rightmost boundary, and then the bottom boundary, and then you end up with the topmost boundary. So here XW minimum is nothing but the clipping window, that is the leftmost boundary, XW minimum, the minimum lower limit. XW max is the rightmost upper limit, that is the rightmost upper limit here, XW maximum. Then YW minimum represents the bottom portion, that is this, the lower limit. And then YW maximum represents the upper limit, that is the top portion of the clipping window. So these are the 4 parameters that you have to set. Once you set this clipping window, now it is nothing but you are selecting the desired portion from the object. So that desired portion will be chosen, or that desired portion will be, you can say that unwanted portion of the object will be clipped off, and only that desired portion that comes inside the clipping window will be chosen, and that will be finally now displayed onto the display window. So here GLU ortho 2D is done, and remember the normalized coordinates. So normalized coordinates always ranges from -1 to 1, and that is default 1. So once you render your image within this boundary -1 to 1, you can say that now your image became device independent. Now you are ready to display the image of the object onto any of the device. It can be a phone, or it can be a laptop, or it can be on their tablet screen. So your graphics is now ready to display onto any device or any output device. So now next we have there the boundary, the clipping window by default. Again, if it is a 2D clipping window, by default the boundary also is set to -1 to -1. So what is -1 -1? So it is nothing but the leftmost boundary is -1 and the bottom boundary refers to -1. So the maximum is nothing but, as I already said, the upper limit, the rightmost limit is +1, and the upper limit there for the topmost area is again +1. Next we have our VPort function. So that is nothing but how to display the final, how to get the image displayed onto the window. So that is mapping. We have just now set up our clipping window. So we are now ready to map the graphics onto our VPort. So what is VPort? It is nothing but a small region on the display window. So a desired region on the display window. So an OpenGL function, you have to set the VPort. So again, the VPort, as I said, it is a desired portion in the display window. So for that you can set up the boundary there. So what is that? At which position you have to start drawing the VPort? Suppose this is my display window, this is my monitor screen. So inside my monitor screen again, I have a display window. So that display window here is nothing but one portion on the screen. So that display window again, you can, within that you can set up a VPort. So that VPort what you're setting can be anywhere inside the display window. So you can say there, I'm choosing one position there somewhere at the center of the display window as the position to draw the VPort. So that position there you specify over here. So what is it? XV minimum, YV minimum. The position chosen to draw the VPort inside the display window is the first two parameters, okay, that indicates X coordinate and Y coordinate of the position. And then your VPort has a width and height. So definitely your VPort has width horizontally and height, that is vertically, okay, vertical. So this rectangular area inside the display window is nothing but the VPort, and the OpenGL function required to draw that is GL VPort. Remember that, okay. So we have the next function there, that is GL get integer function. So this GL get integer function is the one that is required to set the current active VPort. So what is that current active VPort? So this actually says that within the display window we can have multiple VPorts. So we can have more than one VPorts. So in that case, whichever VPort you want to set it as active one, okay. So what you can do, the GL VPort parameter you have to pass as the first parameter, and then you can pass the next parameter called VP array. It is nothing but the 4 element array there. So that 4 element indicates your this above 4 parameters. What is that 4 element array? It contains the position of the VPort and it contains the width and height of the VPort. So these 4 elements will be defined inside this VP array, and then the GL VPort is a parameter that you pass, and this is an OpenGL function there which actually returns the integer value. So what integer value it returns? It returns the current active VPort. So the currently active VPort will be returned, the integer or ID corresponding to this current active VPort. So this indicates that we can have multiple VPorts there within the display window. So out of that multiple VPorts, if the current VPort, if you have to set it, or you can say that if you want to know the current active VPort, so the corresponding integer value of that will be returned there, okay. So next functions we will discuss. Yes, we have now the next OpenGL functions. We have already discussed that in our previous video when we discussed about the sample OpenGL program. All these functions we had discussed. So it is the same thing. So how to create a GLUT display window. So remember, when I say a display window, it's nothing but if this is a monitor screen, inside the monitor screen we can have this entire monitor screen acting as a display window by default, or else I can have one desired portion inside this screen which is acting as a GLUT display window. So how to, what is OpenGL function required to set this desired portion inside the screen? So here we have the very first function called GLUT init, which is required to initialize the GLUT, or in other words it actually refers to interacting with the display window. So this acts as a glue now. So GLUT init function, this acts as a glue now between your library and the window, display window. So your libraries are glut.h, or it can be gl.h, glu.h. So this function actually acts as a glue between your library and the display window. So once this interaction is developed, once this glue is set up, you can say now the interaction is going to begin between your window and the library, okay. So you have to pass the parameters, that is the command line arguments. You can say it is the number of arguments and the argument list. So you have to pass it as a parameter. So this is a very first function inside the main, and without which you cannot have any interaction between the library. You cannot make use of any OpenGL functions which is actually defined within the library, okay. So the next important functions that is required to set up the display window there is the GLUT init window position. So GLUT init window position, you can see the first letters are all in caps, remaining all are in small case. GLUT init window position is the one which is required to set the window position. Your window, display window, I'm speaking about the display window there. that display window can be anywhere inside the screen. So the position you can set up. So usually you can see that the top left corner is by default it is taken as the window position. So you can set up here the top left, and you can say the x coordinate and y coordinate of the leftmost position can set up as a window position, but it is left to you. You can have anywhere the display window on the screen. Next, the window size, always two parameters again for this, that is the width and height. So width represents horizontally, height represents vertically. And then we have the create window function, which actually, this is the function which is actually responsible for creating the display window. Remember, whenever you create the display window, there is one small section on the top of the display window, and that is the title of the display window. You can give your own title for the display window. So here you specify within the double quotes, that is nothing but the title of the display window. So we have three OpenGL functions which is required to set up the display window. Next, we have the next OpenGL functions. Remember, all these functions we are defining within the main, one after the other. Okay, so the next OpenGL functions we have, that is display window mode. So we have this display window mode, and again the OpenGL function to set up the colors and all that. Okay, so we have the display window mode function. So this is a very important function. You call it as glut-init display mode. So this glut-init display mode, the first function, so inside the main again. So here the mode is nothing but, we can have different modes here. So you can just see here the parameter that you're passing is single. So what is the meaning of this? We are making use of a single buffer in the for displaying the graphics. So whenever I say a buffer is the one which actually stores what? Pixels. So what information of pixel is stored in the buffer? One is the position of the pixel. Position, you specify the position in terms of x coordinate, y coordinate. So that indicates the coordinate information. And the one more information that you store in the pixel is the color information, right? So the coordinate and the color information. So the single buffer is enough to display a still graphics on the display window. What is the meaning of still graphics? The graphics which doesn't have any movement, the graphics with no animation effects, right? So that you call it as still graphics. For such graphics, a single buffer is enough. Suppose if I want to have animation effect on the object, that additional effect, movements if I want to have onto my object, then I have to change my buffer from single to double buffer. So two buffers I require, and that is called as front buffer and back buffer. Okay, so we have a color buffer RGB specified, and there is a bitwise OR here, and one more mode is the single buffer. So here we have the mode, that is single buffer, and the color buffer we have initialized. And next we have an OpenGL function to clear or set the background of the display window. So my background of display window can be, by default it is actually black. Okay, so by default it is black. What is the meaning of black? Red 0, green 0, blue 0, and the last value also you can set it as 0. So 4 parameters it takes for clear color. So that is red, green, blue, RGB, 3 primary colors, and the 4th parameter is alpha, which actually can take up 2 values, 0 and 1. So what is the meaning of that 0 and 1? It indicates transparency and opacity. So if I want the background or if I want the display window as fully transparent window, the value I should set it as 0. So if it is opacity, opaque window if I want to have, then the background I can set it as 1. Okay, so the value I can set it as 1. So you can have the background color of the display window by calling the function GL clear color, set it. So if you want red color background, then set it as 1, 0, 0. Green and blue is 0, and the if you want to have an opaque window, you can have the last value, set it as 1. Okay, so this indicates a red background. So you can change. So if you don't want to use this clear color, or if you don't want to set the color, if you don't want to directly use these 3 primary colors, red, green, blue, you can also make use of an OpenGL function called GL clear index. So this actually now makes use of a indexed mode, color indexed mode. So color indexed mode is nothing but it makes use of a color lookup table. You have several rows here in this color lookup table. You have all possible combinations of these three colors, red, green, blue, within this lookup table. And definitely this lookup table, in order to make the search easier, definitely this lookup table has something called as an index. So with the help of an index, you pass the parameter as a proper index here. So with the help of that index, the appropriate color will be searched from the lookup table, and that color is set here for your background of the display window. So GL clear index also can be used to set the background color. Next we have the current glut display window. So what is the meaning of this? See, like I already till now whatever I said was about a single display window inside the monitor screen. This is a single display window. All the OpenGL functions whatever we discussed till now, it is all for the single display window. Now here onwards we will speak about multiple display windows. So can I have multiple display windows that is displayed on the screen? I can have it one behind the other. There can be multiple display windows displayed one behind the other. But remember, whenever I'm displaying the graphics, I have to usually choose one display window. I have to usually choose one of the display window out of multiple display windows. So all OpenGL functions, whenever you're calling, those OpenGL functions will be corresponding to a single display window. But at the same time, whatever the display windows are behind this main active display window, so those display windows will be inactive. So anytime you wish, you can get those behind the display windows, whatever is there in background. So those display windows you can get it to the forefront, okay, by using suitable OpenGL functions. Remember, we can have multiple display windows one behind the other. At a time, one display window will be active. Suppose if you don't want that active display window, you want to move that display window to the background, you can do so, or any background display window you can get it to the forefront anytime using the suitable OpenGL functions. So we will now see all the OpenGL functions with respect to these multiple display windows. So as I already said, this glut create window is the function which is used to actually create a display window. You give a specific title to that, and whenever you call this function, it actually returns an integer value. So what is that integer value that it returns? It refers to there is one unique identification number or integer value that is assigned to the newly created display window. So unique identification number is created and it is assigned to the newly created display window. That unique ID, integer ID, will be actually returned and that value you now can store inside the variable called window ID. So what is this window ID? It indicates the ID of the newly created display window. Now, if at all you want to delete a display window, I don't want this display window to be displayed there, so I can delete that with the help of a function called glut destroy window. But remember, whenever you want to destroy any display window, you must pass a unique identification number that actually corresponds to that display window. So what is that identification number? Anyways, we have stored that in a window ID variable. So that window ID you should pass as a parameter, and with the help of which you can destroy the window. Destroy is nothing but deleting the display window. Next, suppose you want to set a current display window. So what is the meaning of current display window? It is something like I want to get one particular display window into the forefront, into the foreground. So what is that? I want to make a new display window as a current display window. So how do I do that? I can make use of a function called glut set window, and that whatever is there in the background, its window ID you should pass as a parameter. So that background display window, whatever is there, I mean the display window whatever was there in the background now will be set as a current active display window. That means, in other words, you are moving that display window to the forefront. So glut set window is the function in order to make or in order to get the background display window into the forefront. So next we have glut get window function. So what is this glut get window function? This actually returns the ID of the current active display window. So whichever is the display window actively running in the forefront, so its window ID can be returned with the help of glut get window, right? So that current window ID is returned and you can store it in the variable. So all these functions you are using in the case of, in the special case, that is when you have multiple display windows. Let's move on to relocating and resizing a glut display window. Let's discuss about the OpenGL function required to relocate and resize a glut display window. So we have the first function to do that, that is glut position window. So what is this glut position window? You can just see the two parameters passed to that. It refers to x coordinate and y coordinate. It's nothing but the leftmost x coordinate and y coordinate. If this is my display window, and inside the display window if I have multiple this outside whatever I have drawn, the outer rectangle, it refers to the screen, that is the monitor, and here the small portion is nothing but my current display window. Assume that there are multiple other display window, one behind the other, and I have one foreground display window which I call it as a current display window. If I want to change the position, if I want to change or reset the position of this display window, active current display window, I can use this function glut position window, wherein you can pass the parameters as the new position to draw the display window. The new position refers to maybe the left portion, that is the leftmost in the sense, the x coordinate which refers to the left position, okay, and the y refers to the again the leftmost y coordinate. So this leftmost x coordinate and y coordinate, this position will be chosen in order to so you can just see it is top left, not the bottom left, it is the top left, okay. So the top left x coordinate and the top left y coordinate, this particular position will be changed, okay, it will be reset there. So that is glut position window. And next I have the function glut reshape window. So glut reshape window is to change the shape of the window. So that is to change the width and height of the current display window. So the new width and new height you can specify to your to the current display window. So the new width horizontally and the new height vertically will be changed if you use the function OpenGL function glut reshape window. Next I have the function glut full screen. So this display window, the current display window, will be expanded to fill out your complete screen. So your current display window will be expanded to fill out your current screen, I mean the entire screen there, if you use the function glut full screen. Okay, so the next function you have glut reshape function. So this glut reshape function, just know the difference between glut reshape function and glut reshape window. So glut reshape window refers to the current display window width and height, okay. So glut reshape function is the one, this is used to adjust the width and height. So adjusting the width and height in the display window. So you can just see here, if you just want to adjust, so like new width and height you can specify, along with that the window position also you should pass as a parameter. So everything you can define within one user defined function called some win reshape function. So this is a user defined function which you can pass as a parameter there. So what should be the definition of this function? Inside this function you can define a new position. So new position, when I say it is top left and top left corner position, and then the new width and height you can specify, and again within that you can specify a GL VPort function. So what is GL VPort function? There in the GL VPort, within the display window you define one area where that area is nothing but the portion where the graphics has to be displayed. So that new viewport will be as per your new width and height that you have set for your display window. So So that is a glut reshape function that you can define, and remember that is a callback function. So why you call it as a callback function there? It is nothing but this user defined function will be called, and it will be called again and again in order to display the graphics and adjust that graphics to the new display window dimensions. Okay, so that is this glut reshape function. Next, how to manage multiple display windows. What are the OpenGL functions required to manage multiple display windows? You can just see here the first function, glut iconify window. See, on my computer screen, suppose I have multiple display windows. You can just choose a current display window and you can convert that current display window into one small icon. So you all know what is an icon. So whenever you just see your desktop, there will be multiple icons there, right? So every icon will have one image, and also every icon will have one title there. So you can just see here, this window will be automatically converted into one icon if you use the function glut iconify window. And as you know, now icon should have one name. So how do you set a name to the icon? So you have to use an OpenGL function glut set icon title and specify the title for the icon. So that is the title that you mention over here. So next, you can now also set glut set window title. So what is this glut set window title? As I already said, there will be multiple windows, one behind the other, display windows. So whichever the current display window you have, that means the display window which is there in the foreground, which is actively running in the forefront. So for that display window, now you can change the title of that with the help of this glut set window title, and the new window name you can specify here. So changing the title of the display window of the current display window can be done by making use of a function glut set window title. So next, you can just get any display window into the foreground. So that means you can set any display window as a current display window, that is actively running current display window, by just using the function glut set window, and you remember to pass the ID of the display window. So window ID you must pass, and from where do you get this window ID? The moment you call glut create window, that function actually returns a window ID, and that ID you should pass as a parameter here in order to get any display window into the foreground. So once that is done, next, what is glut push window? So glut push window is something like, if I have say around 5 display windows back to back, okay, one behind the other. Now what I can do here is, this actively running, the very first display window which is actively running in the foreground, I can simply push that window into the background. I can just simply push that particular foreground display window into, where I can push that, I can push behind all the other display windows. So this very first currently actively running display window can be pushed behind all the other display windows with the help of this function glut push window. Next, I have glut pop window. So glut pop window is something like, whichever display window is behind, I can just simply get that display window into the foreground. So the display window whichever is running behind, I can just move that, I can pop that and get that display window to the foreground or into the forefront. So that glut pop window I can use. Next, I have glut set window. I guess it is a repetition, so it's the same function. Okay, next I have glut hide window. Okay, so what is this glut hide window here? Glut hide window is something like, I'm just making this currently actively running display window, I'm just making it disappear. Okay, so I'm just hiding this particular active window. I'm just making this to disappear from the foreground. Okay, so hide window. So if at all you want to get back that hidden display window, you can just finally make use of the OpenGL function glut show window. So glut show window will just simply get that hidden window back onto the screen. Okay, so these are the different OpenGL functions that you have, using which you can manage multiple display windows. Next, I have sub windows, multiple sub windows. What is this sub window? Like in my example, I have a screen, and on the screen I have a display window, and I can have many such display windows, one behind the other. Suppose if I want to create one sub window inside the main display window. So what is that? I have one display window currently running, actively running. So within that display window, I will have one small sub window. I can do that. So how do I do that? I can just use the OpenGL function glut create sub window, and inside that glut create sub window, I need to pass few parameters. What is it? The first parameter is window ID. So which display window you have chosen to create a sub window, so that display window's ID you're supposed to pass as a parameter, first parameter. So what is that? Window ID of the display window which is currently running, or which you have chosen to create a sub window, its ID you should pass. So main window's ID you should pass, and then whatever the following parameters you have, the bottom left x coordinate, y coordinate, and then width and height is nothing but the parameters of your new sub window that you have created. So it is the bottom left x coordinate, y coordinate, and then the width horizontally and the height vertically. So the new size of the dimensions of the sub window you are specifying over here. So this is how you can create a sub window inside the main display window. And next, if at all you want to set a cursor shape. So you all know that the moment you open the display window, you get a cursor there on the screen. So usually a cursor will be a blinking line, a horizontal line. So I can change the shape of that cursor into different. So what is that? OpenGL function glut set cursor, and you have to pass a parameter there. And what is that parameter shape? It can be something like an arrow shape. So if I want this shape, what is that? An arrow, up down arrow. So this would be, the cursor shape will change from a blank line, I mean from a horizontal line to a arrow shape. Or if at all I want to have a rotating arrow type of, okay, if I want the cursor shape to be something like this, a rotating arrow, so I can make use of a parameter glut cursor cycle. Remember, all these parameters you can pass here. And then get that cursor weight. This is a wristwatch shape type of cursor. And the last one is a destroy, wherein a skull and cross bones type of shape of a cursor, such type of cursor will appear on the screen. Okay, so these are the 4 shapes that you can give for the cursor. And next I have glut display function. So what is this glut display function I have? So it is something like it's a callback function. It's a very important function that has to be called inside the main, and this is a callback function for which you pass a parameter. It's a user defined function that you pass. So this picture description is a user defined function within which you actually define the vertices, or within which you actually define the color for your graphics, position for your graphics, animation, everything you can define within this picture description. And this function will be called continuously until the user interacts. That function will be called, and the graphics will remain on the display window continuously with the help of, because of this function, glut display function. So I call this glut display function the callback function, which will continuously call your picture description function, and which will be responsible for making the graphics to continuously display on the display window. Okay, so that is glut display function. And then glut post redisplay is nothing but, this is actually you can say it is an alternative to this glut display. This glut post redisplay is the one for which you don't pass any parameter, still it will continuously call your display function. This display function, whatever you have defined inside glut display function, that will be continuously called with the help of this glut post redisplay, so that this glut display function burden on this function will be reduced. Okay, so if you make use of this glut post redisplay continuously, it will just call this display function. So you make use of this usually whenever you display any animation. Okay, continuously your object will be rotating or moving there. So in order to get that effect, you have to continuously call your display function, for which you have to make use of this glut post redisplay. And finally, you have in your main program, that is glut main loop. So that is something like your entire program will get into a loop. So that loop will be broken when the user interacts onto the screen. So the continuously the graphics will be displayed on the screen, continuously an event will be an action will be performed on the display window until a user performs some event. So what is that event processing? So event can be a mouse click or a keyboard key press. Okay, so when user does such activity, the graphics maybe that will be something like a you stop the screen, okay, until the user closes the screen, that will the graphics will remain on the display window. So event processing loop is glut main loop. So finally we have remaining glut functions, that is other glut functions. You can have one special function called glut idle function. So glut idle function is the one wherein you can pass one user defined function. This is something like you have a screen, and on the screen, suppose I have a display window, and suppose inside the display window I have displayed a graphics of a small a cube kind of structure, 3D cube or something, okay, and I want this cube to continuously rotate. You know what is rotating? So it is something like continuously this cube should rotate 360-degree continuously. It should not stop at all. So the moment I execute my program, my display window, once it is drawn, I should see this cube continuously rotating on the display window. So I'm not interacting with the screen, I'm not using any key, or I'm not using any mouse operations, okay. So without my user's interaction, you can see the cube will be continuously rotating on the screen. So for that to happen, you must make use of a function called glut idle function. What is the meaning of this? When the screen is idle, continuously you call this function in such a way that this function's description should be containing all OpenGL functions that is responsible for making this cube continuously rotate. Okay, in order to make this continuously rotate, okay, you need to have certain OpenGL functions like GL translate, GL rotate, and all that. All those functions you call inside this function, and this function will be continuously called until the screen is idle. When this, what is that screen idle means? That means user is not interacting with the screen. So until the user interacts, the screen will be idle. So when the screen is idle, this cube will be continuously rotating, because you have defined all the parameters required for that inside this function, user defined function. Okay, so next we have the last OpenGL function, that is glut get. So what is this? It is to retrieve some information. So you can pass a parameter. So one such parameter is glut window x. So this actually returns x coordinate of the current display window. So I have multiple, if I have multiple display windows, so in that case the current x coordinate, so current position of the display window, that means the current x coordinate of the display window position, that will be returned here if I make use of this parameter glut window x. So one more parameter I can pass, glut window width, or I can pass one more parameter, glut screen width. So what is this? The width of the display window, or maybe it is the width of the display window, or it can be the width of the entire screen. Okay, so that will be returned if I use the function, if I call the function glut get by passing the parameter glut window width or glut screen width. Okay, so these are the other OpenGL functions. I hope all these OpenGL functions are clear, and I request all of you to practice all these OpenGL functions with the help of a suitable OpenGL program.